Right, so in this video we're just going to do a quick recap on electrolysis and what electrolysis is, and then how to answer some electrolysis questions. I've got the basic setup for electrolysis here. We need two electrodes, they're normally made out of graphite, and a DC power supply in the middle, and we're going to do some electrolysis on an ionic compound. And electrolysis is used to where we use electricity to split apart ionic compounds. However, these ions need to be free to move. That's partly so that they can carry the charge between the electrons and complete the circuit, but also so that we can actually physically separate these things. And so the first thing we need to do is to make these ions move, and there's two ways to do that. One way is to add heat, and if we add heat and melt, it needs to be molten, but if we melt these ions, then they're all separate and free to move. So the negative ions will all be able to move freely, and the positive ions will all be able to move as well. They're all jumbled up, and then once they're able to move freely, they're able to move towards the electrons. So the positive ions can move towards the negative electrode, and the negative ions will move towards the positive electrode. That will separate the substance. The other way of doing it, instead of heat, because ionic compounds have very high melting point and boiling point, the other way of doing it is to dissolve them in water to make a solution. So to make an aqueous solution, so dissolving in water will allow those ions to be free to move. Make sure you say ions and not electrons, but those electrons could be free to move. But the problem with that is that water, H2O, spontaneously dissociates and forms H plus ions and OH minus ions. Now, not all water molecules do this, but there's enough present that when you dissolve this in water, that we've got some H plus ions present in the solution, and OH minus ions, which are just going to make the whole electrolysis thing more complicated when we're thinking about what the products of electrolysis are. Anyway, that's a quick overview of electrolysis of molten substances and solutions, and now let's have a look at how we apply that knowledge to exam questions. So, first of all, this question is about electrolysis. It says complete the sentence, choose an answer from the box. It says copper chloride can conduct electricity when in solution or when, well, the other version we just talked about was molten, so or when molten. B, magnesium chloride can be electrolyzed. The diagram below shows two experiments for electrolyzing magnesium chloride. So in experiment 1, we've got a DC power supply, we've got a positive and negative electrode, and we've got molten magnesium chloride. There's that heat to melt this ionic substance. In experiment 2, we've got a DC power supply again, a positive and negative electrode, and this time the magnesium chloride is dissolved in water. As soon as I see that dissolved in water, I know that we're also going to have some OH minus ions and H plus ions, as well as the magnesium ions and the chloride ions. So this one, we've only got the magnesium ions and chloride ions. Right, let's have a look at the question. The question says, explain why magnesium chloride must be molten or dissolved in water in order to be electrolyzed. The answer here is that it's about the ions, and often in an exam that first mark is simply for saying the word ions, realizing that it's ions, not electrons, which are moving in electrolysis. So the ions are fixed position in solids when molten or in solution. The ions are free to move to the electrodes, and that's the key. Right, so free to move and ions are where the mark's going to come from there. The next question is explain how magnesium is produced at the negative electrode. So in experiment 1, okay, so in experiment 1 is this one. So the magnesium produced at the negative electrodes, we drew the ions in here, so there's magnesium 2 plus ion, and it's going to be produced at the negative electrode. So this magnesium 2 plus ion is going to go to the negative electrode, and what's going to happen? So the magnesium 2 plus ion, we work that out because magnesium is in group 2 of the periodic table. The magnesium 2 plus ions are attracted to the negative electrode. Why are they attracted there? Well, because opposites attract. Okay, so the positive metal ions, the positive magnesium ions, are attracted to the negative electrode, and when they get there, they gain electrons from the negative electrode that were pushed around the DC power supply. They're going to gain electrons. In fact, it's going to gain 2 electrons to become an Mg atom. Remember, atoms are uncharged, and they're not ions anymore when the metals get their electrons back. If we wanted to, we could talk about a half equation for this. So what would happen is that the Mg2 plus ions, they gain 2 electrons and they become magnesium, and that's why magnesium is formed at the negative electrode. It says, last question here, it says in experiment 2, a gas is produced at the negative electrode. Name the gas produced at the negative electrode. So in this case, at the negative electrode, we've got a gas being produced. Name the gas being produced. So at the negative electrode, we've got both magnesium and H plus ions being attracted. Well, it's not going to be magnesium. It's not a gas. So the gas that's produced must have come from these H plus ions, and the H plus ions are producing hydrogen. So when this is in solution, the H plus ions preferentially gain electrons to become magnesium. That's because magnesium is higher up the reactivity series than hydrogen. Let's have a look at another question. Similar question on electrolysis of solutions. It says figure 2 shows the apparatus during the electrolysis of copper chloride solution. So we've got copper chloride, and that word solution means we're going to have OH minus ions and H plus ions in there as well. Copper is Cu2 plus, that's our metal. Chloride ions are Cl minus. It says describe what is seen at each electrode during the electrolysis of copper chloride solution. And thankfully for us, this time we've got some clues. Always have a little look at the picture, and what you can see here is that there's some bubbles here, and then we've got this solid forming around the negative electrode. So what's going on at the positive electrode? Well, there's bubbles. We can see those bubbles forming. There's going to be probably a little bit more detail than that required. What gas is that? Are those bubbles made out of? Right, so let's draw the ions which are in this. We've got Cu2 plus ions, and we've got Cl minus ions, we've got H plus ions, and we've got OH minus ions. And these are going to be attracted towards the positive electrode, and so will the OH minus ions. The OH minus ions could produce oxygen for us, but the rule is that where there's a halogen or halide ions in the solution, these are preferentially turned into a gas. And so the bubbles here, they're going to be bubbles of chlorine gas being produced at the negative electrode. Opposites attract, so these positive ions, the Cu2 plus and the H plus ions, are going to be attracted towards the negative electrode. Which one of them is turning into its element there? Well, the fact that there's a solid being produced, not bubbles of gas, means it's not hydrogen. So it is solid copper is forming on the electrode. The reason for that is because copper is lower than hydrogen on the reactivity series. Final question. Hydrogen gas and oxygen gas are both produced when sodium sulfate solution is electrolyzed. Explain how oxygen gas is produced in the electrolysis of sodium sulfate. So, sodium sulfate solution, sodium sulfate solution. So, sodium, Na plus ions, sulfate ions are SO4 2 minus ions, and this again, this word solution means that the water has produced H plus ions and OH minus ions. Explain how oxygen gas is produced in the electrolysis. Well, the oxygen gas comes from these OH minus ions. So here's how we construct our answer. So water, which is dissolving the sodium sulfate, splits apart into H plus and OH minus ions. The OH minus ions are attracted to the positive electrode, where they lose electrons, where they lose their electrons, and so the OH minus ions lose electrons and oxygen gas is formed from the hydroxide ions. Okay? Right, that's how to answer questions about electrolysis of solutions and electrolysis of molten substances. Thanks for listening. Take care. Bye-bye.